All right, let's talk about extracting fossil fuels. All right. And before we go on, before I forget, let me give you another part of the super secret code. It is the number 2. You got me? The number 2. One more time, the number 2. So, let's see. Coal mining. How do we get out coal? We can use strip mining. We talked a little bit about that last unit. And we get that, that's more surface coal, closer to the surface. Most suitable for fairly flat layers of coal, kind of shallow, close to the surface. Single seams, that means like one layer of coal. Sometimes you get multiple layers of coal, but you know, if it's just a single seam of coal close to the surface, strip mining is usually the way to go. Mountaintop removal, also surface, so you can remove up to 800 feet of tops of mountains to try to reach coal seams that are not accessible by other techniques, oftentimes because the terrain is too steep or the veins are too thin. Oftentimes also if there's multiple layers, just kind of removing all this stuff is the way to go. And then there's underground mining. It's more widely used to extract coal, as many coal seams are said to be found deep below the earth, 800 feet or below. So this idea of coal miners, if you ever watched movies or documentaries about it, which you will for the assignment, you know, these people coming out of the mines, just, you know, all covered in black soot, that's underground coal mining. So again, strip mining, which we talked about last unit, peeling off long strips of land to get to a coal. Again, typically a single seam, so a one layer of coal pretty close to the surface. Mountaintop removal, again, steeper areas, just take the mountaintop off, or if there's multiple layers of coal to access, mountaintop removal is often done. You know, all of these degrading the environment. And then underground mining. A lot of it's mechanized, large machines that are helping to mine out these seams of coal deep underground. One interesting kind of way, a newer way of of mining is called long wall mining. So you have a long wall of coal. It's the machine that kind of just goes back and forth, and as it goes back and forth, it kind of eats more and more and more and into the wall, and then you just kind of extract that stuff out. And this whole machinery kind of moves forward, and then any waste that's above will fall kind of behind as this whole machine, this long wall machine, kind of eats into the seam of coal. So yeah, so you can see the back of it here. So as this machine kind of just creeps further and further forward, any stuff that's on top just kind of falls behind as this whole mechanism eats into the wall. So please watch the following video on long wall coal mining. Pretty please, that is required. Watch it. How do we extract out oil or petroleum? Usually it's just simple vertical extraction. You drill an oil well, so you drill a long hole into the earth, sometimes a few thousand feet, sometimes a few 10,000 feet. You put a steel pipe casing that's placed in the hole. Vents are opened in the base of the casing. Oil flows up and they suck it out. It usually flows up under its own pressure. We're drilling so far deep down into the earth, thousands of feet, that remember, the deeper you go, the more heat and pressure. So in essence, if you drill down to an oil reserve, oil deposit, and then you open up the pipe, it's under pressure, so it just wants to shoot out. Kind of like you're shaking up a can of soda pop. You open it up, you give that pressurized liquid somewhere to go, and it shoots out. Same thing here. So oftentimes under its own pressure, once you open up the pipe, it just starts to flow out, and you just kind of pull it out. Sometimes thicker oil does need to be sucked out, but oftentimes these are so deep, under so much pressure, they just kind of flow out on their own. So oil reserves exist typically from about 200 feet to well over 40,000 feet below the surface. So just to give you an idea of how deep some oil wells are drilled. I know this is kind of hard to see, so I'm going to break this down into chunks. So let's look at this kind of top chunk. So this looks at the depth of oil wells. So this kind of gives you an idea of the depth of the Grand Canyon. Some of the first oil wells only a couple 200 feet deep. The average Texas well, 3,500 feet. So now that's about 2/3 of a mile. So you got to drill down that far to get this stuff out. That's pretty darn far. Hydraulic fracking, that's more natural gas, more on that in a little bit. But now we're going to look at some of these other kind of oil well areas. So the Motion 1 onshore oil well, so that's 24,000 feet below the surface. My goodness. Coming back here, looking at, for instance, the BP Deepwater Horizon. That's the oil rig just offshore in the Gulf of Mexico that the pipe fitting, where the pipe hit the bottom of the ocean, it kind of broke and oil leaked out of the bottom well. So the BP Deepwater Horizon, so you can see it's a floating offshore rig that's already, the pipe already needs to go down about 4,000 feet in the water just to hit the ground, and then drilling into the ground 35,000 feet below ground. You got to drill down, put a pipe 35,000 feet. That's 6-7 miles right there. You just got to drill down to get to the oil. That's where we're searching for these things. One of the deeper mines is pushing 40,000 feet. These are way, way, way deep down. Sometimes, again, we find oil on land. Sometimes we got to use these rigs that are just offshore. Different types of barges that may float, that may be attached to the bottom, and some that are just kind of free floating. Some operate, some drill ships operate in waters that are 12,000 feet. So you got to just put pipe and drill 12,000 feet just to hit the ground before you even drill down, maybe tens of more thousands of feet. That's where we're searching for this stuff. It's not plentiful. We're digging to the depths of the earth to get this stuff out. These are non-renewable resources. When they're gone, they're gone. It's best to maybe start shifting away from these things, because when they're gone, they're gone. As far as oil sands are concerned, so that's liquid petroleum. As far as oil sands, the bitumen, mine oil sands are typically less than 50 meters below the surface, a couple hundred feet, but can be as deep as 75 meters, so a little bit deeper, 200-300 feet. Anything deeper as far as oil sands are concerned cannot economically be mined, since too much waste material needs to be removed before the bitumen-rich oil sands can be accessed. Your energy return on energy investment, you're putting too much energy, too much cost in versus what you're going to get out of it, the profit you're going to get out of it. So anything deeper than that is just not worth it. And these are typically mined from surface pits, surface mines, open pit below several meters of overburden. So here's a cross section of some oil sand. So the overburden is the rocks on top. So you got to scrape all that stuff off to get to the dense oil sands, which is only about 7 to 14% bitumen oil content. So about 10% of that is oil. So you're taking all this stuff out to extract 10% of that. You got to filter all this stuff out, all the processing that goes into that, all the land you have to basically rip up and destroy just to get to it. It's very intense. It's a very dirty form of energy. They're all dirty, but this is extra dirty, I guess. So here's an oil sands pit. You can kind of see the overburden here. And so then what they do, so this is all the thick oil sands. They just take the bulldozers and kind of just push it off the sides. And then these big cranes pick it up, put it in trucks, and they'll ship those trucks off for processing. So again, degrading whole large areas. Again, here's some of those big, giant yellow dump trucks. You can see, how big these mines can be compared to these large trucks. Here is a video kind of explaining and showing you oil sand mining. Watch it. It is required. And what about natural gas or shale gas? Similar to oil, you do some vertical drilling, and because we're drilling down thousands of feet, the natural gas in this case is also under pressure. So you drill down, open up the well. Under pressure, it just kind of wants to come out, and you contain it, you put it in pipes, you ship it somewhere. So vertical drilling was the only type of drilling used to extract natural gas up until the 1980s, vertical, just drilling straight down. And then they started to explore horizontal drilling. So what they would use are flexible drilling pipes with a steerable drill bit. So instead of just having to drill straight down, they could drill in any direction they want. It's possible to take a vertical well and steer it and bend it to move over at a target depth and drill horizontally through the natural gas deposit. That way, you know, you have a smaller footprint. Maybe as a natural, so when you own land, you only own that. You don't own the air above it to a certain extent. You don't own everything below it down in the center of the earth. You only own a small amount. So what a natural gas company can do, let's say under your property there's a bunch of natural gas, but you don't want to sell it. So then they buy this property over here, they drill straight down and then over it and get that from underneath your house. Don't you love fossil fuel companies? Shady business. But that's what horizontal drilling allowed for them to do. And again, it's similar to vertical drilling. They just open up holes somehow to extract out the gas, which flows naturally under pressure back to the surface. Now, a third option is hydraulic fracturing, also known as fracking. So drill vertically down, open up the pipe, gas flows out. You kind of drill down and then move horizontally, open up the pipe, it can naturally come out. But if it's really locked into place, low-grade natural gas deposits kind of really embedded in the rocks. It's not just a big reservoir of gas. So we have to do something called hydraulic fracturing, a lot of time with shale deposits, which are sedimentary rocks that have embedded in them natural gas. So in order to get that natural gas out, you really have to break up the rock, then the gas is released and then it comes out. So how do we do that? Well, we can either dig all the way down, get all the rocks, crush it ourselves, and then extract the gas, or we do all that underground. And when we do all that underground, that process is called fracking, hydraulic fracturing. So we drill those same vertical wells, and oftentimes horizontally. Then we pump down hydraulic fracking fluid. It's a mixture of water, sand, and other corrosive chemicals, and that's pumped underground into these wells at very high pressure. It's pumped under the ground at such high pressure that it causes the surrounding rocks to crack. All right, so we're pumping down this hydraulic fracking fluid into these wells. These well pipes have holes in them. This hydraulic fracturing fluid comes out of these holes at high pressure, cracks the surrounding rocks. So you're fracturing these rocks. Those fractured rocks now release the natural gas, right? So the gas that was embedded into these rocks, almost chemically, you're breaking up these rocks, allowing the gas to release. So then, under high pressure, the waste fluid and natural gas flow back out of the pipes to the surface. Sometimes you have to suck it out, but oftentimes just under pressure itself, you're releasing the gas. So that waste fluid and natural gas gets pumped out. So now you have to separate the gas from the waste. That waste has to go somewhere. The natural gas has to go somewhere. So most fracking sites that mine natural gas from shale rock, of fine-grained sedimentary rock, usually do so 1 to 2 miles underground, sometimes deeper. All right. So traditional vertical wells versus kind of going down vertically, horizontally, drilling into solid rock, which there may be methane, natural gas in there, pumping in high pressure material to create fractures, breaks in that rock, then the gas and waste material, wastewater, hydraulic fracking fluid, waste liquid comes out with it. Again, here's another kind of image of the same thing, but that waste fluid's got to go somewhere. So it seems like a good idea, but there's all this waste that goes into it, because now you have this waste water, chemical, sand stuff. It's got to go somewhere. Typically, that's pumped down old natural gas wells that they don't use anymore. They just go and take that and pump it underground somewhere, which can be an issue with groundwater if you're pumping those chemicals into groundwater areas, or if natural gas leaks out into the groundwater. More on that next section. But again, what you're creating here, if you're breaking up the material below ground, what's going to happen above ground? At some point, what you're doing below ground affects what's going on above ground. You can cause, sinkholes. You can cause earthquakes. I mean, you're fracturing the stuff below ground. That's going to have an effect on what's above ground. So we're going to pause here. When we come back, we'll talk about some of the environmental impacts of fossil fuel extraction and use. All right? See you back here in just a second.